of all, if you have a chance while you're here, go up to the second deck. It gives you a different vantage point of the aircraft.
Great.
Appreciation for looking at it from a different perspective. One thing I'd like to point out though is take a look at the wing. And I know it's big, but what is striking about the wing? Its appearance. Now remember, the wing is freestanding; it's not supported. So what do you see in it?
Cantilever wing.
Okay, but what is striking about it? Now remember,
The
the wing.
size.
Okay, no, but think about this: it's 320 feet long. Goes from end zone to end zone on a football field.
Right.
Yet, for a wing that's not supported, it's freestanding. Look how straight the appearance is.
It doesn't appear to be sagging at all.
Right, no sagging, no droop. However, the wing does sag about 6.5 feet at rest, and in flight, it'll rise about 6.5 feet. So we have 13 feet of flex, given a wing that's made of wood, and yet you don't see any noticeable droop.
That's impressive.
Now, who thought of this aircraft?
It's Kaiser.
What was
Wasn't
that?
it Kaiser and Hughes?
Kaiser.
Okay.
Why did Kaiser come up with the idea of a gigantic flying boat?
Because his ships were being sunk.
Exactly.
U-boats.
What this was a concept aircraft designed at the time to fly over the U-boat threat over the Atlantic.
Liberty ships.
Right. Until they could get the resources necessary to start protecting the convoys and suppressing the German submarine threat. So it was a stopgap measure. Okay, so with that in mind, Hughes contacts, or not Hughes, but Kaiser contacts Hughes and discusses the proposal. Hughes is captivated by it. The world's largest flying boat. He's going to design it, which he does. So between the two of them, they collaborate an agreement. Now remember, this is for the war effort, okay? So Kaiser's got a buddy up in D.C. and he thinks, hey, maybe we can get some government subsidies for this, okay? So with that in mind, he talks to his friend, and his friend says, yeah, we can swing this. So with that, Kaiser's friend turns out to be Franklin Roosevelt the President. Friends in high places.
Right.
So with that in mind, he's authorized, Kaiser and Hughes are authorized to build 3 aircraft. Now remember, these are concept aircraft, right? One will be a static display, 2 will be flying prototypes. But now that you're in a contract, you've got to actually start going through the bureaucracy, we'll say. So at that time, the WPA, the War Production Administration, was the agency that was funneling all the strategic materials into the war effort. And they didn't really think this thing was that plausible. So they say, you can build it, but you can't use aluminum, metals. You can't poach skilled labor from the existing aircraft industries. And should this thing turn out to be a success, you can't sell it for a profit. So with that in mind, you start building, what are you going to build it out of? Now the nickname Spruce Goose implies that you're going to use spruce material. Actually, the Spruce Goose was an ugly nickname that stuck to the aircraft, and that was by a reporter. The actual nickname was Hercules, which is quite fitting for the size of the aircraft. Okay, so with that in mind, Hughes comes up with the idea not to build it for spruce, but actually for birch, primarily because of the construction qualities of birch wood and its abundance. Okay, here's a Trivial Pursuit question. What British aircraft company successfully built a wooden twin-engine aircraft?
Do you have one?
De Havilland, Mosquito.
Yeah, I was thinking you need to get one here for the size difference.
Right comparison. But De Havilland's Mosquito was excellent.
And they used wood for that for the same reason that wood was used for this.
In fact, De Havilland was contracting with many of the American lumber companies for birch itself to use as their construction.
You wouldn't want to use that Home Depot lumber these days.
I don't know, there's lots of curved places in it.
Yeah.
Okay, so
true.
Again, our material is made from birch. I'm going to take a look at this now. Okay, so how many of us here have ever built a Gillows balsa wood aircraft back in the day?
Quite a few.
And how did we put them together?
Pardon me?
How did we put them together?
Stuck it together.
Glue,
Yeah. Oh, yeah. Those. Yep.
and we used pins to put it on the schematic, right? Well, essentially Hughes does the same thing. If you come over here, you're going to see that he takes very thin layers of the birch material And he basically makes a plywood style product. He calls it Duramold. He uses adhesives, temperature, pressure, and an electrical current to form essentially plywood construction panels. He glues the aircraft together, but to keep the aircraft together, he will invent a nail and he'll insert it just like a roofer uses a pneumatic gun. He has a pneumatic gun that inserts the nail. Then after the glue is dried, he pulls the nail to recycle it. And in doing so, he saves 16,000 pounds of weight in nails alone.
Wow.
Now think about this. The aircraft was finally assembled in November of 1947. Disassembled back in the late 90s, transported up here, put back together again. And think about this. The aircraft, as you see it, is as it was manufactured back in the 40s. And it's not falling apart. Okay. Now, the aircraft is supported downstairs in the cradle. It's in a cradle. Now think about this. Since they put the aircraft back together, they measured the amount of droop from the pontoon to the floor. There's only been about a half-inch noticeable sag since it was displayed.
That's amazing.
How long ago?
This was I think it was in the early 2000s. Yeah. So again, it's a testimony to mechanical engineering. How many miles of electrical wiring are on this aircraft?
All of it.
Well, what do you think? Take a guess. Now the B-17 had about a mile of electrical wiring.
Say about 20 miles.
26 miles of electrical wiring.
Wow.
How many linear board feet in miles? What do you think?
40.
Close. 29.
Wow.
Okay, and again, 94% birch material. And again, you can see the structure. Of course, you need to have metal for plumbing, wiring, generators, etc. Okay, come on down here. Okay, so something about our power plants, our engines. We have 8 Pratt & Whitney 4360s. They're one of the most powerful reciprocating engines built at its time. Now the engines are very thirsty. They're going to drink about 120 gallons of fuel an hour. Now under ideal conditions, this aircraft would have about a 3,000 mile range. So in theory, it could probably fly across the Atlantic in about 19 hours. So with that in mind, a lot of fuel is needed for this aircraft. So Hughes designed the aircraft to have 14 fuel tanks. On the right side down the catwalk, there's going to be compartments that also hold styrofoam blocks. Again, Hughes wants positive buoyancy. The ladder represents our initial access up to the flight deck. So the crew would go through the wing. And we'll show you what it looks like upstairs. Now for our pilots. Okay, so when we refer to redundancy, backup systems, what we have right here is a hydraulic power station. Now, if you're to lose primary hydraulic power, this would be our backup station to control the aircraft. Now, suppose you had an electrical failure. Well, each motor would have a bank of batteries that would give it about 20 minutes of life. Within that 20 minutes, you might be able to troubleshoot your primary problem, bring the primary system back online, shut this down. Also, if you look overhead, you'll see what looks like 2 teardrops. Anybody got an idea? Our pilots should know what those are.
ADF antennas?
What?
ADF antennas?
Well, they're a direction finder. Back in the day, they'd use those radio direction finders to home in a radio
The
station.
skin is radio transparent.
The ladies man too. Okay, let's make our way back to the rear of the flight deck. Recall the ladder downstairs? This is where they would make their entrance into the flight deck before they put the staircase up. Come on, gotta come back here. Generally speaking, the flight crew would be a crew of 11, maximum 22. Now, the wing has a thickness and height of over 11 feet. So the engineers could walk into the wing upright to every engine station. Generally speaking, there'd be 2 engineers in each wing at all times with fire extinguishers available. The reason being, during landings and takeoffs, fire would be a big risk. Now remember, the fuel was downstairs. However, if you look at the size of these green wing tanks, the tanks inside, well, they hold about 350 gallons, maybe more. But inside each tank, there's a float valve. Now, you think about your toilet, it has a float valve. So when you flush it, it goes down and then it kicks up automatically to a safe level. Same thing for the fuel tanks. The fuel drops down below a certain level, it'll automatically kick back on. So remember, all your weight and balance and fuel is downstairs. Also behind you, you'll notice a gigantic oil tank. Think about the fact that the engines will burn down with oil and oil. So, electrical circuit boards, fuel lines. Okay. Black boxes, these are essentially our canaries in the coal mine. They're going to monitor your air quality. Now, if you recall, there's 8 engines on this aircraft, 8 aircraft engines. However, that's not true. We actually have 2 more, and they're going to be right here. These are basically our auxiliary power units. They're going to provide the aircraft with electricity. Why 2? Remember, one fails, you get a backup system. So, once you turn an engine on, it's running, you can now supply power to the engines outside, and the pilot can turn on an engine. And the engines, 4 of them, will be able to generate electricity, and 4 of them will be able to power hydraulic units. Again, backup systems. What do you suppose this hatch is for up here? Well, what comes to mind? Get up on top of the wing.
So you can go out and work on the engines, probably.
Well, that's true. But what do you suppose its primary purpose is?
Yeah.
Yes.
Also the sextant. To
Sexting? Navigation.
navigation.
Okay, that comes in second. The primary purpose is this right here. When you're looking out the cockpit, you can't see what's behind you. Your field of view is very limited.
Right.
So Howard has an observation post put up here. So during landings and takeoffs, we can have somebody to be his eyes and see all around for safety hazards. Primary purpose, observation, navigation, engineering needs, escape hatch. Now think about this too. Remember downstairs at our backup hydraulic drive station, there was a bank of batteries to give supplemental power to the power drive units. If you had a catastrophic electrical failure, there's a bank of batteries here that will provide energy to the airplane to keep it running for a given period of time. Like I say, maybe during that moment you can get the primary system back online, or possibly, if you had to, safely set the aircraft down. Okay, crew of 11, you're off duty. Can you imagine the noise up here?
Yeah.
Okay. I don't know if hearing protection was really a priority back then. But let's say you want to kick back. So you sit down, got all this leg room. First thing you do is you take out your Lucky Strikes and you light up a cigarette. Back in the day when smoking was still common. Okay, notice overhead here on the fuselage. You see these straps? These straps were designed to monitor the structural integrity of the fuselage. If you can imagine all the dynamics going on, if one of these were to pop free, it might indicate a weakness in the fuselage. In which case, if you look overhead, you're going to see blue numbered stations. They run down the length of the fuselage, and again, their sole purpose is to document a location. Okay, let's come forward. Now remember, this is a test aircraft. We have multi-engine heavy. So the engineer wants to make sure that the propellers are all online, performing in sync with each other. You don't want to have a asymmetrical power base because it could set the aircraft off. You want to have, like I say, a balance of power. So think here too, now back in the day, you just didn't have one black box flight recorder. You had many. So the flight recording station is going to document the various functions of the aircraft. Coming over here, you'll notice this contraption. This is where our filtered air comes out for Howard. More specifically for the cockpit, that tube that's over on the left side of the seat, that's filtered air just for Howard, his own personal needs. Okay, we talked about redundancy. Remember this contraption? Okay, coffee dispenser. Okay, what are the 2 most important positions on an aircraft this size?
Pilot.
Pilot's one. What's the other one?
To start,
No. So the two most important positions on the aircraft.
Engineer.
Pilot and engineer, exactly. What does the co-pilot do?
Back up for the pilot.
Well, he gets coffee for the pilot. Okay, come forward here. I'm sure.
No, for Howard Hughes especially.
Okay. So think about the engineering station. Again, engineering station. Remember we talked about electrical and hydraulic generation? The throttles represent the engine that's responsible for an electrical generation or hydraulic power. Over here's our communication station. Probably a navigator's position too. Okay, we got to start closing the chapter on the Spruce Goose.